In this video, we will look at dividing complex numbers with a binomial, meaning two terms. In order to divide a complex number with two terms, you have to use the conjugate. So the conjugate is taking the first term, changing the sign of the second term, that's the negative 3i, to a positive 3i. And what you're going to create is equivalent of 1. You're going to create an equivalent fraction using a multiplier top and bottom that would cancel to be 1, which is the negative 5 plus 3i over negative 5 plus 3i. Now, the conjugate will give you what is called difference of squares. The difference of squares means that for the bottom, and this is where the difference of squares is, you will not have a linear term, meaning you will not have an I when you get done. So let's proceed to multiply. And if we do this, then we got distributive, right? 9i times negative 5 is negative 45i. 9i times 3i is plus 27i squared. Now, on the bottom, it is negative 5 times negative 5 plus 3i, negative 3i times negative 5 plus 3i. What I'm doing is splitting the binomial, right? First term times everything in the second, then the second term with its sign times everything in the second parentheses, right? Now, we're going to multiply. So let's kind of draw this. And we've got negative 45i. And let's just go ahead while we're here. That's 27 times negative 1, which would be negative 27. So we went ahead and took care of some of the stuff up top, but let's finish on the bottom. Okay, so that's 25 minus 15i plus 15i minus 9i squared. All right, so let's clean up this. This is negative 9 times negative 1, which is plus 9. This all becomes 0. So I got 25 and 9. 25 and 9 will give me 34. And then I'm going to write it negative 27 minus 45i. At this point, I need to look at the trifecta, meaning the three numbers, to see if I can pull out a GCF. And from this, I see no GCF. So we should be good. Or GCF greater than 1. So, all right. The second problem that we have is now you still got the binomial on the bottom, but you have a binomial up top, which just means you're just going to multiply two binomials twice. Okay, so first things first, I got a complex number in the denominator. It's a binomial, so I need to multiply top and bottom by the conjugate, which would be first term stays, second term changes signs. The negative 8 minus 8i over negative 8 minus 8i becomes 1, right? So let's split it. Negative 9 times negative 8 minus 8i. That's the first term times everything in the second, right? Then negative 7i times negative 8 minus 8i. And then we'll change colors for the denominator. So we'll take this term times everything. So that's negative 8 times negative 8 minus 8i. And then plus 8i times negative 8 minus 8i. All right, so if you expand it like that, then all you have to do is it's just distributive property twice. So let's do the top. So that is, we'll do this, 72 minus 50, no, plus 56, because, no, wait, plus 72i, get my math mind going straight, plus 56i plus 56i squared. Now, let's multiply the denominator. And that would be 64 plus 64i minus 64i minus 8i squared. So let's go ahead and take care of the top. This is 56 times positive 56 times negative 1, which is going to give me negative 56. And that's 72 minus 56. So if my math is good, that is 16. And then 72 plus 56 would be 128. Now that's on top. On the bottom, this becomes 0, which is what it's supposed to do. If it does not become 0, the i's cancel out in the bottom, then you've done something wrong. This will give you negative 8 times negative 1, which is plus 8. So you got 64 plus 8, which would be 72. Now, I'm not sure. Would 4 going to 72? Let's see. 4 going to 72, because 4 would probably, I'm not 16, mate. We can try 16 real quick to see if it will give us the greatest common factor. And let's see, 72 divided by 16 is 4.5, so nope. So let's do 72 divided by 4. Okay, that's 18. And then 128 divided by 4 is 32. So 4 will go into that. 4 plus 32i all over 18. And I'm looking at that. It can still go again because 4 wasn't a GCF, 8 was. So let me do it again. Sometimes you may pick the wrong GCF. Mine went to 4 and 16, but 8 was really. But I can check it and do it again. So that's 2 plus 16i over 9. And that should be the answer because I can't pull out anything else in my trifecta. So if you pulled out an 8 as a GCF, then that's what you got. But if you pulled out a 4 like I did to begin with and then double checked it, I checked it again to make sure that I couldn't pull anything out and then realized I could. So that's why I know it was 8. Then just be mindful of that, okay? But those are your 2 looks for your binomial in the denominator for complex division or division with a complex number, okay?